What's up, everybody? I'm going to go ahead and go over the one-dimensional kinematics review sheet. You should definitely try these problems first. The answers are in parentheses, and then watch the video, or at least watch the section of the video that you need to. If you have any questions, please comment below. I'm also looking for some video requests, so if you'd like me to go into detail in a type of question, again, just go ahead and write in the comments below. Let's get started. Alright, let's do problem number 1. Again, pause the video to see if you can solve it. The answers are in parentheses, and then come back and watch if you need to. So when you do this, remember you're always trying to identify 3 variables that are provided for you or given to you. So for example, in this problem, we have our bike rider. Okay, we don't know how fast they're moving to begin with. That's unknown. So we'll say that's unknown, be initial. Now we do know the bike rider speeds up and eventually reaches a final velocity of 10 meters per second. So let's write that as our final velocity is 10 meters per second. And the time it takes for that to happen is 5 seconds. And the distance that the bike displaced is going to be 40 meters. So remember, you're looking to find 3 known values, and once you know 3, you should be able to find the other 2. So in this case, the initial is one unknown, and then acceleration is the other. So once you have your 3 givens, we're just going to go ahead and try to figure out what the 4th one is. So in this case, we have the initial, we have the final, we have time, we have displacement. So we want to look for the equation that will help us with this. So in this case, we're going to be using this particular one. Delta D equals VO plus VF over 2 times time. Okay, so in this case, our displacement was 40 meters. Our V initial is unknown. V final is 10 divided by 2 times T. Okay, in this point, it's just an algebra problem. Actually, we do know the T, don't we? So let's go ahead and write that in. So the T was 5 seconds. Okay, so we'll multiply both sides by 2. That gets me 80. We'll divide both sides by 5. That equals VO plus 10. So 80 divided by 5 is going to be, what's that, 16? Equals VO plus 10, so VO should be 6 meters per second. Okay, and that's it. Question number 2 is asking for the acceleration, or letter B. So now we're just going to choose an equation that helps us find the acceleration. In this case, I'm going to use V final equals V initial plus AT. So my V final we said was 10. The initial was 6 plus acceleration, and the time that it took was 5 seconds. So it's going to be 10 minus 6 divided by 5 equals A, and that gets us 4/5 meters per second squared, or 0.8 meters per second squared. Alright, let's move on to question number 2. So question 2, go ahead and see if you can solve this. Pause the video. Let's write out our variables first here. So we're looking for V initial, V final, or these are all the variables we could know. There's always going to be 5 variables, and we're trying to find 3 of the 5. Once we have that, we should be able to find the other 2. So in this case, we have our car. Looks like we're on like a hill or something, and so the car is initially sliding backwards. This way, it says the speed is 30 kilometers per hour, and then we hit the gas, and the car will start to slow down, reverse direction, and then speed up in the upwards forward direction, eventually reaching a speed of 50 kilometers per hour. And at that time, or at that point, it's 5 meters ahead of where we started. So our givens are fairly obvious here. We have 30 meters per second. Now we are going downhill, so we're going to make that a negative number here. So we're going to go negative 30 kilometers per hour. And then the upward, we're moving 50 positive kilometers per hour. And then the last thing, 5 meters, is the displacement is 5 meters. So there's our three givens. Now the one thing you do have to notice is that we're in kilometers per hour. So we're going to need to convert that to meters per second. So let me just remind you how you would do this. So let's do it for the 30. So if we have 30 kilometers per hour, let's convert kilometers first. So we know 1 kilometer is 1,000 meters. So that converts to meters per hour. And then we know 1 hour has 60 minutes. So that converts to meters per minute. And then we know 1 minute has 60 seconds. So that's now going to convert to meters per second. So we're going to multiply the top and then divide everything by the bottom. When you do that, for this particular one, you should be getting 8.33 meters per second. So remember, this is going down, so let's just fix that. So that will be negative 8.33 meters per second. Alright, and then you'll do the same thing with the 50. And I'm not going to do it all out, but when you do it, you should get 13.9. And that would be positive here. Alright, so once we've done that, once we've converted, now we can go ahead and set up the problem. Alright, so again, we know three things. The first question they're asking about is the acceleration. Okay, so we'll just choose an equation that works for us. Let's see. I'm going to choose this one here. VF squared equals VO squared plus 2a delta d. Okay, so we just plug in our numbers that we know. So this was 13.9 squared. And then notice this one, we're going to go negative 8.33, but we're going to square that. So that will eventually become positive. Alright, we do some algebra here. Here, I'll do the algebra out just so you can see it. So this would be 193 when you calculate it. This one here would be a positive 69.4. And then if we do the math, 2 times 5 equals 10. Okay, subtract that, so 193. A lot of students will divide. Remember, you're subtracting here. And then we go 193 minus 69.4. That gets us 123.6 equals 10a. So our acceleration would be essentially 12.36. Again, this is going to be meters per second squared. Let's look at the next question. We're asking about time here for the next one. So whenever possible, try not to use a calculated value when solving for like a part B. So in this case, I'm going to go ahead and use this equation, delta D equals VO plus VF over 2 times the time. That way, in case I make a mistake with this acceleration, I'm still okay. So delta D was 5. Now remember, V initial is negative, so that's important here. 8.33. And then V final is positive. Divided by 2 times time. Notice this is really just like an average velocity. And so your average is going to be quite small here. What's the average? 2.785. It's quite small, and that's because we're going down and then we're going up. So the average is going to be very small. In fact, if these two are the same, it would be 0, right? The average would be 0. So anyways, the time is simply going to be 1.79 seconds. The last question is asking about the motion. I kind of described it earlier, but just to reiterate, you're heading downwards. We're going to be slowing down on our way down. We're eventually going to stop right here, and then we're going to head back up, speeding up, and then we end up 5 meters ahead of where we started. All right, next question. So in this question, we are dropping a rock from a bridge. Okay. And it's just going to undergo free fall. And we want to analyze the motion. So again, we set up our variables. I'll just do them as we go. So v initial, when it says drops, that tells us right away that the initial velocity is 0. The time is given, that's 8 seconds, right? And then it's in free fall, so we know the acceleration, it's going to accelerate downwards. So we're going to say acceleration is negative 9.8, and again, the negative is just telling us that we're moving down, accelerating down. All right, there's our 3 givens. Let's go ahead and solve for the fourth. So we'll use this equation, delta d equals VOT plus 1/2 AT squared. So our displacement's what we're looking for. V initial we dropped, so it's 0, plus 1/2, negative 9.8. And then the time squared is 8, so we'll square that out, and we get a displacement of negative 313 meters. Okay, remember the negative's just telling us that we're below where we started. Now I think the question said like how high. Typically high is from the ground up, but at this point it doesn't matter, to be honest. You just understand the difference. Question B, that was A. Question B, we're looking for the final velocity. So again, if possible, try not to use the equation that has displacement in it. So in this case, we'll use this one. So V final we're looking for, V initial is 0 plus negative 9.8 times the time, 8 seconds. And our final velocity is going to be negative 78.4. Again, remember the negative is essentially telling you the direction. You could alternatively say down here if you wish. Question 4 is an interesting question. So why don't you again pause and see if you can solve this. So in this question we have our car. Car's moving along at a speed of 20 meters per second. Now somewhere in front, like a little cat, can't really draw a cat, but there's my cat, jumps out in front. And so we don't stop immediately, we react. In that time to react, we haven't braked yet. And so the car is going to keep moving for a short period of time. Now in that time it takes us to react, it's going to travel a certain distance, right? And so what we have to do, we have to realize accelerating. But in this region over here, I'm decelerating, right? I hit the brakes, I'm at negative 8. And so those equations that we use, those are only based on a constant acceleration. When we have 2 different accelerations, we got to break it apart into 2 different regions. So for example, in region 1, it took us 0.3 seconds to react. Our velocity was 20. Now, that's both the initial and the final, right? Because we're moving at constant speed. So that means the distance we travel is going to be 20 meters per second times 0.3 seconds, or 6 meters. So this distance we travel right here is going to be 6 meters. Then we hit the brakes, right? So for this next region, well, if we're moving 20 from here to here, then we're still moving 20, right? And change my color. So we're moving 20 from here to here, so that means we're moving 20 right here. And then we're going to hit the brakes and stop. So that means we're moving 0 as our V final when we stop. And then we have our deceleration. So those are our 3 known values this time. So we're going to find the distance, essentially the braking distance here. All right, I'm choosing the wrong equation. I want this one. Vf squared equals Vo squared plus 2AD. So our final was 0, we stop. Our initial was 20. Don't forget to square that. We're going to go 2 times negative 8 here, and the displacement is what we're looking for, right? Okay, so we're going to get 400 plus negative 16 times d equals 0, or 400 divided by 16 equals d. Okay, and what do we get when we solve that? 25? So that means in the braking distance we're going 25. Now the question asked how far, what's the total distance? So we're just going to add those two distances up. 25 plus 6 gives us 31 meters. That's the total distance that we travel. Alright, question 5. Again, go ahead and pause the video, see if you can solve it. So this is a rocket problem. So we have a rocket down here. It's going to shoot up. It's going to come back down, right? There's a number of questions that are being asked here. So the first thing is, how long will it take to reach the maximum height? Now if you notice, the total time is 11.2. Since we're landing at the same height, we can assume that it's symmetrical. So that means if the total time is 11.2, that means the time up, so we'll say time to the peak, should essentially be 1/2 of that, right? 1/2 of 11.2 equals 5.6 seconds. Question B, what's the initial velocity? So for this, we're going to use the motion up to the peak, because at the peak we know something very special, and that is that the velocity at the peak is 0. When we go perfectly vertical, but it's assumed to go up perfectly vertical, straight up and down, so the velocity at the peak then would be 0. So the v at the peak would be 0. Okay, and then we know once the rocket's been launched, the only thing acting on it is gravity. So the acceleration is going to be negative 9.8 meters per second squared. And there's our three things. So you choose an equation. We're looking for v initial in this case. I'm going to use this. Vf equals Vo plus At. So Vf would be the velocity at the peak, which is 0. V initial is what we're looking for, negative 9.8, and then this took, remember we're just going up to the peak halfway, so that would be 5.6 seconds. Alright, do a little bit of algebra. You get a V initial of, what is that, about 55? I think it's a little less, but we'll just round it to 55. Question C, now we're just looking for the displacement to the peak. So how high until it reaches that peak. So that would be our fourth variable. At this point you have several equations you could use. I'm going to use this one. 2AD. Okay, so again, the velocity at the peak is 0. The v initial we just found, that would be 55 squared plus 2, negative 9.8, and then we're looking for the displacement. So you square that velocity, 55 squared, subtract it, right, and that equals, what's that, negative 9.8 times d. And so for your displacement, delta d, don't forget to square that. When you do the math, you get about 154 meters as our displacement to the peak, the maximum height. Okay, now there's a number of conceptual questions, so let's just hit these one by one. What's the total distance that it travels? Well, it's going to be going up 154, and then it's going to come down 154. So the total distance would be 154 times 2. Okay, so what's that? 308. That would be our distance. Now displacement, remember displacement's how far from where we started. So if we started on the ground and we ended on the ground, then our displacement total would just be 0. because we're at the same place that we started at. All right, letter E, velocity when it's first launched. We already found that, right? That would be the 55. The velocity at the peak, we already found that. That would be 0. Right before it lands, well, again, if it's a symmetrical journey, the speed up was 55 up. That means the speed down, velocity down, should be 55 down. Okay, or you could put negative 55, but the key is just understanding that it's moving downwards. All right, what is the acceleration? So this means once it's in the air. What's the acceleration? Obviously, when it's being launched with the jets, there's going to have it's going to be going upwards, but in this case, it's once it's launched. So on the way up, it's slowing down, right? We're getting slower and slower and slower. That's because there's a deceleration of 9.8 meters per second squared. On the way down, it's a acceleration, speeding up, 9.8. In both cases, the direction's down, but in one case it's slowing down, one case it's speeding up, but they're both down. And then at the 0, it is not 0 at the peak, it is still moving down, right? We're just changing direction up here. So it's still going to be negative 9.8. So the answer to that question is negative 9.8 down everywhere. All right, so letter G is actually a new question. So I'm going to kind of move this stuff out of the way a little bit. So this question's asking, all right, let's say our rocket lands like on a building or something. Okay, and I'm drawing it as 2 dimensions. Next unit we're going to do 2 dimensions. Let's just assume that it's, you know, kind of more or less going up and then coming back down and landing here. Okay, so again we're going to set up what we know. So the initial we found is 55. Again, the acceleration is negative 9.8 meters per second squared. And then the displacement was given. That was the height of the building. So that would be, I think that was 10 meters. You double check. Yeah, 10 meters. Okay, and then we're looking for time. Now we did this question in class, and if you remember, you end up using the quadratic equation. So I'm not going to do it that way, just so you can see a different method of solving it. And the way I'm going to do is I'm going to first find V final, and then I'm going to find time. So it's not the best way to do it, as mentioned before. Usually you should just find the time directly. But let's see if we can do it without having to use the quadratic. So let's find V final. So for V final, we'll use this one again. VF squared equals VO squared plus 2AD. VF squared equals 55 squared plus 2 negative 9.8 times delta D, which we know. Oops, we do know that, don't we? 10. Okay, so VF squared equals whatever that is. Okay, I'm going to just write the answer here. Now don't forget to square root, so I'm going to just put whatever that is. Sorry, I didn't have time to calculate it. But you're going to get a VF of basically 53.1. Now remember, when you square root, it's a plus or minus. Plus or minus. So if you look at our picture, clearly to land on the roof, it has to be on the way down. So we're going to make that minus 53.1. All right, and then we just finish it up. So let's choose an equation that can get t. And this is actually the nicest equation, right? So we use this one, VF equals VO plus AT. Just remember, we're going to use the negative 53.1. And then this was positive 55 plus negative 9.8 times t. So those of you that did solve this using the quadratic, you should get the same answer that we're about to get. which is 11 seconds. Actually, you would have gotten 2 answers. So the first answer I imagine would have been really small, okay, maybe like 1 second or something like that. But we know since it's on the way down that it should be the second answer is the correct one. So I hope that was helpful. Let me know if you have any questions on any of these problems. You can just go ahead and write a comment down below and I will try to answer you. Alright, and again, if you have any other videos you'd like me to make, same thing, just write a comment and if I have the time, I'll go ahead and give it a shot. Thank you.